Hi, John. Do you want to introduce yourself to the audience real quick?
Sure. I'm John Urschel. I'm a assistant professor here at MIT Math, and yeah, it's nice to chat with you.
Yeah, awesome. So I met John this summer and I had a great time. Can you tell a little bit about your background and how you ended up here, like a little bit of your math journey?
Yeah, my math journey is interesting. So when I was a kid, I really liked puzzles. I really liked playing games, like quantitative mathematical games. Really liked reading math books, but I didn't really know sort of like what to do with that, like what you do with that. And so when I got to college, I started majoring in engineering because my mom told me to. She thought like, oh, you're good at math, you're good at physics, you should be a rocket scientist. So I majored in aerospace engineering, and then I don't know, I just found my college math classes were my favorite. My math and physics classes were my favorite, and I ended up just starting to take some more advanced math classes in college. And after that, I realized that I really did enjoy my math classes the most. And so then I switched to math. Um, I took a class on like advanced calculus, you could call it, like calculus with proofs. I took a class like that in my second year of my undergrad. And the professor saw some potential in me, offered to do a research project with me. And then once I started doing research, I really like took to it. And I sort of knew I wanted to get a PhD in math and like I wanted to do research.
That's awesome. So I know that you had a little bit of a background in football as well. What made you decide make like that full switch, like and
Yeah,
really
so I was so I played sports most of my life. You know, I played football for like a good portion of my life, and I was sort of like doing both at the same time. Like I played sports in college, which helped like to pay for college. I also played after college a bit, and I would say like I enjoyed doing both, but eventually like I realized that like one became more of a priority for me than the other.
Mhm.
And like, also being able to devote more time to that and also like time to my family.
That's
So,
awesome. How does it feel like teaching and in combination with the research and especially like leading math roots and those types of programs?
yeah, so I mean, it's very different. Like, research, you're really trying to do cutting edge things that like solving problems that no one has been able to solve yet. And the teaching aspect is, it's different, like, but it's also very enjoyable in a way. And when I say teaching, I'll talk first about, let's say, teaching MIT undergrads or MIT PhD students. You're sort of training people, the next generation of like great young thinkers, you know, how to do math, like how to use mathematical tools, how to think through a problem, and just more generally making them well equipped to like go out in the world and solve whatever sort of types of problems they're going to encounter in their specific discipline, and which in many cases is not exactly like mathematics or research mathematics. Mathroots is a very different like animal just because okay, it's high school students. Also, it's only 2 weeks. It's like a very different vibe, but it's also just something I really enjoy, and I like sort of like you bring in a bunch of high school students and you show them a lot of new math and you just like throw the kitchen sink at them and see what sticks. And I find it's much more chaotic than like a class, but it's also like very enjoyable in a different way.
That's really fun, yeah. And I feel like the bonds made there very nice as well. Um, so can you talked about your research a little bit. What is the research that you're doing right now?
Right. So that's a good question. So my research sort of spans what would traditionally be considered like three different disciplines. So I would say like probably the main area I work in would be called numerical analysis, which is the idea of finding sort of like efficient and accurate solutions to like numerical problems, problems of like continuous mathematics. So the idea is there's some algorithmic problem you want to solve, and to solve it quickly and accurately on a computer would be my main area. But also, I do some work in combinatorics. So, around sort of like understanding properties of discrete structures and, just combinatorial type questions. And then I also have a decent amount of overlap with like theoretical computer science, which has a little bit more of a focus on discrete algorithms.
It's really interesting. I would personally be interested to know a little bit more about um in the theoretical computer science, like what are some of the what does that entail?
Yeah, so theoretical computer science, like unlike maybe like numerical analysis, is more concerned with sort of theoretical algorithms for discrete problems. So, examples of this might have to do with questions around, maybe I'm trying to think of a good example, but let's say in machine learning, you have some model and you want to learn the parameters of some model from some data. This is a typical like application of theoretical computer science. Or you have some algorithmic problem, like maybe drawing a graph in a certain way to minimize some objective function. What's the complexity of that? What are algorithmic lower bounds? Or even you want to think about fundamental operations like multiplying two matrices and ask how quickly can you do that?
Mhm.
And the sort of algorithmic lower bounds and sort of upper bounds, these are things that people traditionally study in theoretical computer science.
It's really interesting. Um, so yeah, speaking of like as research is a very continuous thing, what are some goals you have as you continue in your math career and like where do you see all of this going?
I would say goals is sort of a maybe a strange thing for me because okay, when you're a high school student or an undergrad or a grad student, you're constantly like looking forward and looking ahead to the next thing. I'm a professor now, and okay, I'm an untenured professor, but I'm a professor, and so in some ways, what my job and what my day and what my responsibilities look like now is probably going to be, very close to what it looks like in 10 years and 20 years. And I would say my goals are to solve interesting math problems, try to learn more, learn more techniques, learn more ideas. The more sort of like ideas you can learn, the more powerful you are, and just have fun doing it. And so, there are certain problems that are really interesting to me that I'd like to make some progress on, but I wouldn't say I have any specific goals in mind per se.
That's a great sentiment. Yeah, and kind of like I guess going off of this idea of like as we learn math, it's just like purely fun, right? That's like in a sense when you're saying that. What is something that maybe you would want to say to educators, especially because I'll show this like out to educators, um, on how maybe we could promote math and make it more engaging or allow it, people to have that platform. Because oftentimes, especially like in secondary school or like rising up, it's often like people will say, oh, like we're not math people or something like that. Do you have any advice there?
Yeah, I mean, I would say one of the things that can really help that sort of thing is not thinking of math as, especially early on in school, you can sometimes get this like the wrong impression that math is somehow like some set of algorithms to just solve like these problems you have to solve. Like there's just a set of rules and then you just do them and then you get the answer. Because that's often how it can feel early on.
Yeah.
But really, I think like the true power of math is sort of a language and a set of like skills and tools that allow you to cope with like the quantitative world around you and to like communicate and talk and think about that quantitative world. And so really I would focus on stressing like not the like, stressing like how well you're performing or stressing like your ability to like memorize certain techniques, but rather like your ability to just learn things and try to become a better thinker and a better problem solver through doing mathematics.
It's a good sentiment there because I think in that way, like you're gonna see if you're able to, if you are enjoying that, and then if you are, you can keep going along with it. And then final question is, like, if one, is there anything else you wanted to share, and then two, like, kind of, is there any advice you have to aspiring young mathematicians?
Uh, I'm not sure I have anything extra to share. I would say for aspiring young mathematicians, my best piece of advice would be probably to try to take control of your own education. Like I would say, don't wait around for your your math teachers to teach you everything. Like there's a very big world out there. If you're curious, just go out there and start learning stuff on your own. And just go start reading stuff, start looking stuff up, and just start, just keep being curious and don't wait for people to teach you.
Awesome. Thank you so much.
Yep.